Good day, ma'am. For problem number 1, the topic is all about the vertical stresses in soil. Refer to the soil profile shown in figure below. We are asked to calculate the variation of total stress, poor water table, and effective stress with depth. Then, if the water table rises to the top of the ground surface, what is changed in the effective stress at the bottom of clay layer? Then, how many meters must the groundwater table rise to decrease the effective stress by 15 kilonewton per meter squared at the bottom of the clay layer? So now, as we can see this figure, I labeled this 5 meter for the sand layer as H1, then the 4 meters for the clay layer as H2. So here are the givens, the given rather, the void 1 and the void 2. We have here the 0.52 and its specific gravity 2.66. Then the void 2 1, then its specific gravity 2.75. Then first we have to find the dry unit weight of the sand, since this layer of the sand is no water involved for this layer, or this is not saturated, since the water table is in this point at point B. So simply follow the formula in order to get the dry unit weight of the sand. We have here the specific gravity times the water unit weight over 1 plus the void. So since these all variables are given, the specific gravity 1 is equal to 2.66 times its water table. The water unit weight is 9.81, and over 1 plus its void 0.52. Then calculate this. Then we have found out that the value of dry unit weight of sand is equal to 17.168 kilonewton per meter cube. So since this dry unit weight of the sand is required for getting the total stress of its depth, the depth of the sand. So since its formula is the dry unit weight of the sand times its depth, so easily for the getting the value of the total stress, substitute the value of dry unit weight of the sand is equal to 17.168 kilonewton per meter cube times its depth is equal to 5 meter. So we have the value of total stress at depth of the sand is equal to 85.84 kilonewton per meter squared. So now for the layer of the clay, since the clay is saturated, we have to find the saturated unit weight of the layer portion, the layer of the clay. So the formula for the saturated unit weight is the specific gravity 2, which is 2.75, times the void 2 is equal to 1 over 1 plus void 2 is also equal to 1 times its water unit weight. Then substitute those given values, then we have come up with this answer for this saturated unit weight of the clay is 18.394 kilonewton per meter cube. Then, since we are able to get the saturated unit weight, then we'll proceed to the total stress. The total stress at the bottom of the clay. So, we will find the total stress from the point A to point C. So, simply multiply this the formula is equal to the dry unit weight of the sand times its depth plus the saturated unit weight of the clay times its depth. So since these are all given, so simply substitute these given values. Then we have here the result value for dry unit weight of the sand times its depth is 85.84. Then our saturated unit weight is 18.394 times the its depth is equal to 4. Then calculate this. Then we have found out that the total stress at the bottom of the clay is equal to 159.416 kilonewton per meter squared. Then here we have the pore water pressure at the bottom of the clay. So simply multiply the water unit weight times its depth, since at the sand layer it is not saturated, so for that layer the pore water pressure is 0. So we are able to calculate the clay layer since it is saturated. So then we have come up that the pore water pressure at the bottom of the clay is 39.24 kilonewton per meter squared. Then for the effective stress at the top of the clay, since the layer of the sand is not saturated, there is no water involved for the sand, so the pore water pressure is equal to 0. Then simply follow this formula. The effective stress times its total stress at the top of the clay. That the total stress for the top of the clay is equal to 85.84. Then minus the pore water table is equal to 0. Then our effective stress at the top of the clay is equal to 85.84 kilonewton per meter squared. And then for the effective stress at the bottom of the clay, so simply follow this formula. The total stress at the bottom of the clay is equal to 159.416. So here, then the pore water pressure at the bottom of the clay is 39.24. So the effective stress at the bottom of the clay is equal to 120.176 kilonewton per meter squared. So we are done with the question letter A. Then let's proceed to letter B. So the question is, if the water table rises to the top of the ground surface, what is the change in the effective stress at the bottom of the clay layer? So now yung water table kay naa sa point A, nisakan yung water table, so the sand is also saturated. So since nakuha na nato ang saturated unit weight sa clay, so kuha na po nato ang saturated unit weight sa sand, since but nga na siya since ang sand kay nanay tubig. Then the formula for the saturated unit weight is the specific gravity plus the void times the water unit weight plus 1 plus the void. Then since this is all given, these are all given, so excuse me, simply substitute all these given values, then we have found out that the saturated weight of the sand is equal to 20.524 kilonewton per meter cube. The saturated unit of clay is 18 here 18.394 kilonewton per meter cube. So now let's continue. The effective stress when the water table is at the top of the ground surface. So this is the formula for getting the effective stress. So first, let us calculate first the total stress. So the total stress is simply multiply the saturated unit weight of the sand times its depth, and the plus the saturated unit weight of the clay times its depth. So substitute these given values, then then we have come up with this value for the total stress is 176.196 kilonewton per meter squared. And then let's proceed for the poor water what we call this, the poor water pressure, 9.81, the poor water pressure from A to C. Since nisaka niya water table, so our poor water pressure for the poor water pressure from A to C is 9.81 times 4 plus 5. So the sand is involved na kay since nanay siya poor water nanay siya value sa poor water pressure since nikasaka niya water table. So 4 plus 5 is equal to 9, then multiply it to 9.81, then we have the poor water pressure from point A to C, then we have 88.29 kilonewton per meter squared. And then for the let us come back here for the formula. In order to get the effective stress, we have the formula. Effective stress is equal to the total stress minus poor water table, water pressure. Then easily substitute this na value nga itong nakuha sa total stress is 176.196 minus ang poor water pressure is 88.29. Then we have the effective stress 87.906 kilonewton per meter squared here. Then since the main question is change in effective stress, so the change in effective stress, so this is our the new effective stress. Since our old effective stress is 120.176, which is already nakuha na to gaina mo ni siya nara 120.176 kilonewton meter squared. So simply simply subtract the old minus the new, then we have found out that the change in effective stress is equal to 37.27 kilonewton per meter squared. For the last question, we have here how many meters must be the groundwater table rise to decrease the effective stress by 15 kilonewton meter squared at the bottom of the clay layer. So what I have done is I make a figure. I was assume that the since here in the question it was stated that the groundwater table is rise. So I was assumed that its groundwater table is in here. So since the groundwater table rises, since the groundwater table rises, then so I was assume that it is in here. Then denoted that the height I denoted this as h, and then the here it is 5 minus h, since the distance from A to B is equal to 5. So let us first calculate the total stress first. So the total stress for this is, since for each layer we have to add the layer A total stress for from A to C. So for A to B, we have here the A to D, the dry unit weight of sand, since the water table is diri ra tama ng water table, so sa diri nga part dry ni siya. So the dry unit weight of the sand times its ang iyang height niya kay 5 minus h, so multiply 5 minus h plus the saturated unit weight of the sand is equal to the saturated weight of the sand is mo ni siya kaning from D to B, from point D to B, then yang distance kay h, so multiply this as h, then plus the saturated unit weight of the clay is from B to C, yang distance kay 4, so nara siya, multiply na to by 4, and then substitute na to ang value sa dry unit weight sa sand, since given ang dry unit weight sa sand, saturated weight sa sand, then saturated weight sa clay, then its depth, ang depth sa clay given na, so muna substitute lang, then simplify, then we have come up with this, the 3.356H plus 159.416. Simplify lang. And then the pore water pressure. The pore water pressure is nadri siya, since yung groundwater table kay nadri atong pore water pressure kay from D to C. So natay distance na 4 plus H. 4, since 4 ang distance niya h, dayon 4 plus h, and then simply multiply 9.81 times 4 plus h, so then simplify makuha tag 39.24 plus 9.81 times h. So napay variable nga nabili, no. So then para makuha na to ang effect, the what we call this, the meters, kung pilay height ni taas ang groundwater table, so ato gamiton ng formula sa effective stress, since natay value sa total stress og sa pore water table. Then substitute lang dayon nato ang value sa total stress og pore water table, so mo ni siya 3.356H plus 159.416 muna itong total stress, minus the 39.24 plus 9.81H nga muna itong pore water table. Then ang ato ang effective stress kay, since atong effective stress kay 120.176 na given na siya, tapos ang giingon dire kay ang effective stress kay ni decrease of 15 kilonewton per meter squared. So simply subtract 15, then kuan nanda yan, simplify nanda yan, substitute nimo ang kaning sign, may mo siya negative, then simplify by using basic addition and subtraction with same terms. Then we have come up with this, minus 15 is equal, negative 15 is equal to negative 6.454H. Then our final answer is equal to the height of the water table rise is 2.324 meter. So that's it. Thank you.